Good afternoon. My name is Cecilia Angara. I'll be presenting slides 1 to 4, and my other colleague Silika should be presenting slides 5 onwards. So our topic for this oral presentation is quantum mechanics. So moving on, what is quantum mechanics? Quantum mechanics is a fundamental theory in physics that describes the physical properties of nature at a scale of atoms and subatomic particles. The purpose of the presentation could be problem-solving approach. Engineers frequently face challenges that demand creative solution, highlighting how quantum mechanics equips them with analytic tools to address and resolve such issues underscores its practical significance. Question can be asked is how can understanding quantum mechanics revolutionize the way we approach modern engineering challenges from electronics to energy? The first idea for quantum mechanics is wave particle duality. What is wave particle duality? Wave particle duality is a fascinating concept that bridges classical and quantum mechanics, making it highly relevant for engineering students. Some key points of wave particle duality, as it's stated on the slide: foundation of quantum mechanics, engineering innovation, and quantum computing. What is foundation of how does foundation of quantum mechanics relates to wave particle duality in quantum mechanics? So, foundation of quantum mechanics, it understands wave particle duality essential for grasping quantum mechanics, which underpins many modern engineering applications. And for and engineering innovation, it recognizes quantum effects, allows engineering to push the boundaries of technology from quantum cryptography to advanced medical imaging. Moving on to quantum computing, the principles of quantum mechanics, including wave particle duality, enable the development of quantum computers, which promise revolutionary advancement in computation. Moving on to the next idea. The next idea is uncertainty principle, also known as Heisenberg uncertainty principle. What is uncertainty principle? Uncertainty principle, a cornerstone of quantum mechanics, has profound implication for engineering students. The 3 points that helps in the uncertainty principle, as it's stated on slide: limits of measurements, designing quantum devices, innovation in measurement tools. So, limits of measurement. The principle highlights the inherent limitations in measuring certain pairs of physical properties, such as position and momentum, with absolute precision. This is crucial for engineering working on nanoscale systems where quantum effects dominate. Designing quantum devices. Understanding the uncertainty principle is essential for developing technologies like quantum computers, where precise control of quantum states is required. And for innovations in measurement tools, the principle drives the development of advanced measurement techniques and instruments such as scanning, tunneling, microscopes, and quantum sensors. Moving on to the third idea.
Hi, my name is Silika, and moving on to the next slide is energy is quantized by H. What is energy quantization? Energy quantization is a fundamental concept in quantum mechanics with significant implications for engineering. Under this topic, we have 3 points. Semiconductor physics. Semiconductor physics is the quantized energy levels of electrons in atoms and solids that are crucial for understanding the behavior of semiconductors, which form the basis of modern electrons. The second is photonics and lasers. This is the concept of energy quantization that explains how photons are emitted or absorbed in discrete packets, enabling the designs of lasers and other optical devices. And the last one, innovative engineering solution. Recognizing energy quantization allows engineers to develop cutting-edge technologies from solar cells to advanced medical imaging systems. And moving on to the next slide. Moving on to key evidence of the three ideas. First one is wave particle duality. Double slit experiment states that electrons or photons fired one at a time through two slits create an interference pattern on the screen to show typical wave. The second one is uncertainty principle. Heisenberg uncertainty principle states that you cannot simultaneously know the exact position and momentum of a particle. And the third key evidence is energy quantization. Planck's blackbody radiation law states that energy emitted by a blackbody could only be explained if energy is quantized in packets. Next slide is the conclusion. To conclude, wave-particle duality is a fundamental concept in quantum mechanics, stating that particles such as electrons and photons exhibit both wave-like and particle-like behavior, depending on how they are observed. This dual nature challenged classical physics and led to the development of quantum wave functions, where particles are described by probability waves. Heisenberg uncertainty principle for quantum mechanics is that certain pairs of physical properties, most notably position and momentum, cannot both be known with absolute precision at the same time. This is not due to limitation in measurement tools, but fundamental property of quantum system. It implies that the act of measuring one quantity inevitably disturbs the other, introducing inherent uncertainty into prediction. And the last one, energy quantization in quantum mechanics is that energy in atomic and subatomic systems is not continuous but exists in discrete levels of quantum. This means particles like electrons can only occupy specific energy states, and transitions between these states involve the absorption or emission of fixed energy amounts. And that's all for our presentation today about quantum mechanics. Thank you.